All right, so welcome everybody. Thanks for coming in. Thanks for joining us. My name is Caroline. I'm from Nanogene Solutions, and I'll be your speaker today. And our topic for today will be pipetting techniques and pipette calibration and adjustment. All right, so a quick outline on what we will be covering today. First, we'll be talking about different pipetting techniques. We'll do a forward pipette and a reverse pipette and when to use them. All right, second, we'll talk about how to calibrate and adjust your single channel pipette. We'll teach you all the math calculation and figure out if you need to calibrate your pipettes. And we'll also be talking about our plastic consumables from BioC and our company's commitment in providing quality products with low cost. All right. So before I start, I just want to let you guys know that I'll be using a Top Science pipette for the demo later on. All right. Okay. Hold on. Let me. Okay. All right. So before we talk about our pipetting guideline, our pipetting techniques, let's go through some pipetting guidelines and precautions that we should know. So I'm holding my pipette here. This is a Top Science pipette. So the first thing, hold on, all right, so I'm holding my pipette right here. Is a Top Science pipette. So first of all, this is the operating knob. So whenever you're using a pipette, make sure that your operating knob is always being handled slowly and smoothly. You know, don't rush into pressing it. This is your tip cone, and your tip, you should always find a suitable tip. For example, this is a 20 to 200 microliter tip, so I'll be using a 200 microliter tip. And every time you're using a pipette, make sure that your tip is firmly attached to the tip cone. And it's important to remember that the temperature of your tip, your pipette, and your liquid that you're using are always at equilibrium, so always the same temperature. When you're holding your pipette, make sure that the main handle should be resting on your index finger, like this. And when you're aspirating, hold your pipette upright, not slanted or anything, and keep the tip constant depth with the liquid that you're using. So I would always suggest 1 cm below the surface of your liquid. And one thing that a lot of people don't know is that you should always try to pre-rinse your tip before aspirating liquid. And for example, you can fill it and empty it 3 to 5 times before you actually aspirate it and move your liquids around. So after pipetting acid or other corrosive liquid that emits vapor, you should always clean your pipette. Make sure that your pipette is always in a good condition by maybe rinsing your tip cone, your piston, your O-ring with distilled water. And of course, do not pipette your liquid between the temperature of more than 70 degrees Celsius or less than 4 degrees Celsius. This is to ensure that your piston or your tip cone is always in a good condition. And as a pipette user, you always want to make sure that your pipette is always in a good condition. And one way to really make sure that your pipette is in good condition is to never allow water to go into your pipette. So how do you do that? How do you prevent liquid from entering the tip cone? Is to never lay your pipette on its side. Always hang it on your pipette stand or somewhere else. And always, like I said, when you're doing operating knob, make sure that you're doing it slowly and smoothly and not really rigid. And of course, obviously, never turn your pipette upside down. All right. So we'll continue into the technique session. So today I'll be talking about 2 techniques. There will be a forward pipetting and a reverse pipetting. and I'll talk about when to use both the techniques. All right. So I am putting my tip into my tip cone right here. All right. So for pipetting, it's something very simple. It's something that you've learned during your undergraduate lab exercise. So first thing you'll do, I have a orange dyed distilled liquid right here. And first thing I'll do is that I will go to the first stop. I'll stop in mid-air in the first stop. All right. And then I'll dip my tip in under the surface. I would say about 1 cm under the surface. And then I'll aspirate it. All right. So I have it, and then once you aspirate it, it's kind of important to make sure that there's no excess liquid. So one good tip is to just touch it against the surface of your reservoir. All right, so you want to dispense your liquid. So with that, you just gently press operating knob to the first stop. All right, and then after a delay of 1 second, continue to the second stop. So there you go, you've emptied your tip. All right, so in mid-air, you just slowly release your operating knob to a resting position. All right, I think this is quite simple. So let's move on to the reverse pipetting. Oh, sorry. Okay, reverse pipetting. So a lot of you might not know, but for reverse pipetting, it's suitable for dispensing liquid with probably higher viscosity. You would think about maybe glycerol or blood serum, or liquids that have a tendency to foam easily, like bubbles easily. So you can also think about maybe if you're planning to dispense your liquid into a 96 bar plate, then this would be a good technique to use. Also, it'd be good for smaller volume. If you're handling smaller volume, you could also try reverse pipetting. So also quite straightforward. Let me just put my tape into my tape. All right, so a little bit different from the first pipetting technique, the forward pipette. I want to just go all the way down. So to the second stop, all the way down in mid-air. All right, and then I would dip my tip into the liquid and then slowly release it all the way up. All right, and then touch the edge to the reservoir, the wall, to make sure there's no excess. So yeah, I already have mine. All right, so you want to dispense your liquid, right? So for the reverse pipetting technique, you want to dispense your liquid only to the first stop. All right, only to the first stop. And what you do is you just discard. You don't really want to use this because once you pull it all out, it might bubbles up or anything. So you just want to discard the remaining of it by just, you probably can discard it with your tip or discard it in another tubes instead. So yeah, that would be the reverse pipetting technique. The only difference is probably you want to use, when you want to aspirate your liquid, do it to the very end, the second stop. And when you want to dispense, only stop at the first stop. Okay, all right. All right, so this would conclude the pipetting techniques. So we've learned 2 techniques today, and then I will continue in how to calibrate your pipette. All right, so before you want to calibrate your pipette, you need to know where is your pipette at. Is it good? Is it working the way it should? So there's a way to test that. So before you test, you will need a few device and some condition. So first thing you'll need is an analytical balance, a digital analytical balance. Test liquid, you can choose distilled water, and a calibration room that is in room temperature and have the appropriate humidity. I would say above 50%. That would be useful if you want to reduce any evaporation during your reading. All right. Okay, hold on. All right. So you have all your instrument and you're ready, you have the room. All right, so you want to move on to checking your calibration. So with the pipette, there is actually 3 checking volumes that you need to know. So for example, like I was using a 20 to 200 microliter volume pipette. So let's use that as a guide. Oh, sorry. So let's use that as a guide. So 3 checking volumes. The first checking volume would be the maximum volume of your pipette. So my maximum volume would be 200 microliter. All right. So the second checking volume would be 50% of the maximum volume. So 50% of 200 microliter would be 100 microliter. And lastly, you will be using the minimum volume, which is, for me, in my case, would be 20 microliter. All right. So now we know that we have 3 checking volumes to look at. So how do we go about that? So with each 3 checking volumes, you want to do 10 series of pipetting. So for example, you would calibrate your volume into the maximum volume, which is 200 microliter volume, aspirate your liquid, and then dispense your liquid to a weighing machine, and then you want to read the readings. So you do that 10 times. So for each volume, you will have 10 readings. Forward pipetting technique is recommended in this test. And at the end, you'll be calculating inaccuracy and imprecision for these 3 volumes. All right. Okay, so here's the calculation part. So first, you would have on your hand 30 reading. So 10 readings for each test volume, all right? So first thing you need is to calculate your mean value. So you want to convert your weight reading into a volume for each testing volume. So first you want to find a mean value, X bar. So using that, you just add up 10 readings, 10 weight readings, and then divide it by the number of reading. So the number of reading obviously would be 10. Oops, sorry. All right, so N would be number of reading would be 10. Once you have your mean value X bar of each volume, you want to find the mean value X V bar for each testing volume as well. So using that, you will use the formula that you found in the mean value X bar times the conversion factor. The conversion factor is probably fixed if you're using a distilled water. For example, if you're using distilled water, it will be 1.004. So as simple as that, you'll find the mean value, V bar of each testing volume, the maximum, the 50%, and the minimum value. All right, once you have that, I will be calculating 2 things, the inaccuracy and imprecision. So what is really the difference between inaccuracy and imprecision? So for inaccuracy, is also known as systemic error. All right, it's kind of like an error that you can predict. It's always going to be a bit higher or maybe a bit lower, and it may be caused by your pipette. So if you have trouble going within the range of an inaccuracy, it can mean that your pipette needs some more calibration. And all right, so let's learn how to calculate inaccuracy. So inaccuracy is in the value percentage. So you use the mean value that you've calculated above and minus the particular volume at which the reading are checked at, V0. So for example, you're using the maximum value of the mean value. So you want to minus the maximum value that you're checking at. So that would be 200 microliter. And you divide it by, again, 200 microliter times 100 and make it into a percentage. All right, so with that, you'll get your inaccuracy value. All right, so let's move on to the next calculation. All right, the next calculation is imprecision. So that's also known as random error. And it's different from a systemic error, also known as inaccuracy, because it's kind of like an error that you really cannot predict. It can be because of your technique, it can be because of your environment. It's something that you really cannot blame on the pipette, but you can always look into your techniques and your environment to solve this. So also very straightforward, you want to find a standard deviation first for each of the checking volume. And you want to follow up with the imprecision formula, which is CV percentage. So with that, your formula would be times 100 times the standard deviation that you found, and divided by the mean value. So you do this also 3 times to check for each checking volume. All right, so at the end of it, you should have 3 inaccuracy value and 3 imprecision value. All right, so once you have that, you can always compare your results to tables. All right, so because I'm using a top science pipette, the manufacturer will always give you like a table, to a range of tables to see if your pipette is within the range, or kind of like a table to tell you where your pipette should be at. So I was using 20 to 200 microliter pipette. All right, and then I checked for the maximum value, which is the 200 microliter, and the 100 microliter, which is the 50%, and the smallest volume, which is the 20 microliter. All right, and then on the very back of the table, you see the accuracy range and the imprecision range for each of the testing volume. All right, so let's say I have the result already. I did my 10 pipettings for each testing volume. I calculated my accuracy and precision, and this is the results that I got. All right, so you can refer to the results below. I did 3 inaccuracy. I have 3 inaccuracy values, and I have 3 imprecision values. So in total, I have 6 values. So how do I know if these values are within the range, and how do I evaluate them? So let's take a look at inaccuracy. So I'm looking at 200 microliter. So my value is 0.04%. And I look at the table that my manufacturer gave me, and if my pipette is valid, the accuracy range should be within 0.6 to minus 0.6%. All right, so positive 0.6 to negative 0.6. Within that range, if my value is within that range, my pipette is, is still good. I don't really need to calibrate it. So I'll give you like 5 seconds to think about it if this is my value is actually within the range. Yeah, so yes, it is within the range, because 0.04 is within the range of 0.6 to negative 0.6. Okay? All right, awesome. So let's move on to 100 microliter. And again, it should be within 0.8 to negative 0.8%. And yes, it is within that range, because 0.036 is within that range. All right, so let's move on to the smallest volume that I'm checking. So it's 3.788%. And in my table, it says that everything should be right if it's within 3 to negative 3%. Yeah, so it is actually out of the range. It's a bit higher, right? It's 0.788% higher. So unfortunately, our pipette is out of the range. All right, so that kind of indicates that you might need to calibrate your pipette, and your pipette might not be working the best that it's working. So let's just leave it there, and let's look at the imprecision. So I'll give you guys 10 seconds to look at the imprecision, my value, my calculation, and then you can compare it to the table above. And if you could, point out which testing volume is actually incorrect. I mean, it's actually out of the range. So yeah, like I think most of you have already figured out, it's actually the smallest volume that is out of the range. So what does that mean? It means that probably when you were testing your liquid, when you're measuring your weight, something might have been wrong, or maybe the technique has been wrong, some human error or anything. Yeah, your eye level might be wrong. So yeah, that is something that you cannot really change. You can just acknowledge it and maybe try not to make the same mistakes again. But when we're talking about inaccuracy, when it's out of range, it is something that you should look into if you want to calibrate your pipette. So let's talk about calibrating your pipette. So I always tell any pipette owners that if you really want to calibrate your pipette, you realize that you need to calibrate your pipette, always go to a professional. I wouldn't really recommend it if you calibrate your pipette yourself, because it's very time taxing and it requires a certain techniques to really get it right. So always just go on to a professionals to have it done. But if somehow you really want to calibrate yourself, your manuals will always give you kind of like some steps to do it. So this is, for top science, this is our calibration technique. So usually, right. So usually we have a window right here. All right, so we usually just pop up. I won't really show it because my pipette is still good. Usually, yeah, also it's good to mention that if you have a new pipette, you just bought your new pipette, your pipette is usually pre-calibrated. So you only need to really measure and test your pipette 3 to 6 months, really depending on the use of your pipette. All right, just a little tip. So here, for my pipette, I would just need to pop up this kind of label window, and there will be a red kind of slider. I would just need to slide it back, and then it will kind of unlock this operating knob right here. And once you unknob, you can actually turn it clockwise or anti-clockwise to adjust your values. All right, so it's very simple. Some pipettes are simpler than the other, but always, like I said, always, if you need to calibrate it, if you doesn't have time to check it, there's professionals who will do it for you, and usually it doesn't take too much time for them. All right. Okay, so all right, so here is just some troubleshooting. You've already done your calibration, everything checks out, but when you're doing your, when you're handling your pipette, there's still some troubles here and there. And one of the most common problems that a pipette user would face is tip dripping. So liquids that don't aspirate, or there's some leakage. And I would say it's the most possible cause of this problem is unsuitable tip. you always want to know that what volume of pipette you're using. For example, I'm using 20 to 200 microliter, so I would need to use a 200 microliter tip. And I also need to know that the head of my tip is actually fitting into my tip cone. So a lot of people, they don't really know, and they just got the wrong tip and everything. But it's fair. It's important for you to understand your pipette and to know that the appropriate tip to use. And of course, there's more other problems that you might face, and you can always refer back to this table if you have any kind of problem. Of course, you can also send us a question if you have a problem that you really want to solve in the chat. All right. So as we're talking about tips, hold on. Okay, so talking about tips, there's actually 3 types of tipettes. So there's a universal type, a Gilson type, and a Pendorf type. All right, really depending on your pipette. If you're using a Pendorf brand type pipette, then you should use the appropriate tip. But usually a universal tip is what people go for. And I will show you in a few seconds some options. All right, so for us, our plastic consumables are from Biosyn, and these are the pipette tips that we offer. We offer 3 of those different types of pipettes. And we always, if you're not too sure what type of pipette pipette tip that your pipette can fit into, you can always contact us. We can always give you some sample tips. We can demo some for you. Just feel free to reach out, and we're always here to help. And aside from pipette tips, Biosyn also offers a range of plastic consumables such as centrifuge, 50-15, microcentrifuges, 1.5 mils. You also have racks to hold your tips and your tubes. Of course, we have the cryogenic series. We have the boxes, the tubes. If you're doing any PCR, we do have PCR tubes and plates. And we even have ranges from the cell culture series. All right, so that concludes my sharing on pipette techniques, pipette calibration and calculation, as well as our Biosyn plastic consumable series. If you need any, if you have any questions regarding this, you can always put it in the chat, or you can unmute yourself, and I would be happy to answer your question. All right, any questions? Also, if any of you are interested in looking up on our e-catalog for our plastic consumables, leave us your email, and we'll be happy to email you our e-catalog for the plastic consumables. Of course, same thing goes with the pipettes. If you're interested, if you're looking into it, if you want to do a little demo session, yeah, always let us know. All right, any questions from? Also, feel free to unmute yourself, or if you're shy, you can always chat with us on the group chat. Okay, so we have a few questions here. Okay, bye. Okay, Okay, so from Hamida, how much is the calibration by a professional? Feel free to email us for the price. Of course, you can always let us know your the brand and the volume that you're using. Let us know the information through email. We'll be happy to revert back it to you. Okay, how to maintain the pipette for long-term usage? Okay, so how do you protect it? All right, so we mentioned it in the slide. There is some precaution. Hold on, let me go back to the slide. Let's see. All right, okay. Wait, hold on. Oh, wait. A little technical difficulties. Okay, so right here, so I talked about some guideline precaution, and I think to summarize it, just be very gentle with your pipette. Always, if you don't have a pipette stand, I think it would be really good to invest in a pipette stand. Just to make sure that your pipette is always upright. You don't really want to lay it around so that anybody can like hold on to it or anything. And I think the most important part is when you're aspirating and dispensing your liquid, you really want to prevent your liquid from going into your device, your instrument. And that really is critical. I think if you want to maintain the lifespan of your pipette. So by doing that, it's just being really mindful when you're handling your pipette. And really invest in a pipette stand. Okay, hi. So from Afika, hi, for the accuracy value in your example, 2 of the values are in range while the others is not in range. You still need to calibrate the pipette even if one value is not in range. I would say yes. I think it would be wise to calibrate your pipette even if one is not in range, because you would see like in the table from before, the range is actually very large. So when you are calibrating your pipette, when the professionals are calibrating the pipette, they will calibrate it in a way that every volume is in range. So you really don't have to worry like, oh no, like my first two testing volume is in range. I don't really want to mess it up. You don't really have to be fearful about that, because they would make sure that 3 of testing volumes are in range. So for your answer to that, I would say yes, it would be really wise for you to calibrate that pipette even if you find that one of the values are out of range. Okay, all right, so let's see one more. Procedure to verify. Hold on, let me check some. All right, so how to autoclave your pipette by Asila. So okay, so every pipette is different. There are pipettes that you have to disassemble, and then maybe pick out a few of the springs that cannot be autoclaved. But for our pipette, Topsign pipette, you can actually just put your entire instrument into the pipette machine and the autoclave machine to autoclave it. But it really depends on your pipette. For us, it is fully autoclavable. You don't have to disassemble anything. Just put the whole thing into the autoclave. But again, I want to mention, it depends on every pipette. I would say read the manual. It will always come with the manual. Your pipette should always come with the manual. Read them and see what really fit your pipette. Okay, so for anyone who is using our Top Science pipette, it is fully autoclavable, but again, check with your own pipette manual. Okay, all right, so for Hanli, for verifying accuracy, all right, 5 readings of max volume to calculate mean value is sufficient? No, I would say always go with 10 readings, right? So for every volume testing volume that you're using, use 10 readings. So you need to do it 10 times. You want to aspirate it, dispense it to the weighing, and then read it, and then do that 10 times. So you get 10 readings. 5 readings can be a little bit too little. So for a safe side, I would suggest to go for 5 readings. Okay. Procedure to verify pipette accuracy is same as your procedure to check calibration. Yes. So as I said, hold on, let me get into that slide. Hold on, yeah, Hanli. Okay, yes. So your question is the calculation for inaccuracy kind of like validating if your pipette needs to be calibrated? Yes, you're correct. So when you're calculating inaccuracy, you want to be very mindful. If anything out of the range of inaccuracy, it means that your pipette needs to be calibrated. So that is what inaccuracy can tell you. That would be the systemic error. So it will be kind of like an error that you can predict, something that your pipette is probably in not a very good condition. So just follow the table and follow the table of your pipette. The table that I'm using is Top Science pipette. So if you're using, maybe you're using a QMax pipette, then you should be using their table of volume. All right, I hope that is clear for you. Okay, same as procedure. For sterilization, okay, so from Abdul Rahman, okay, your question is for sterilizing of pipette, which method will be appropriate? Okay, so either using a UV light or ethanol, but really based on your own pipette materials. If your pipette materials cannot really withstand harsher liquids or anything, I would say UV, but always read the manual. For us, we can use either for Top Science pipette, we can use either UV or ethanol. So it's pretty hardy. But most of the pipette in the market, I would say read your manual first and then decide if you want to use UV or ethanol. And same thing goes with autoclaving. Read your manual first. Yeah. All right. Any other question? All right. If anybody has any question, feel free to WhatsApp us or email us to the email that is provided by my colleague in the chat. Yes. So thank you so much for stopping by and joining us in this sharing. Again, we do have more webinars coming up. Next week, we'll be having a next generation sequencing webinar on genomics and transcriptomics. I think it will be really helpful, even for beginners, if you're not too sure what they are. I think this is a very great introduction, and even for veterans who want to know more of the technology that PGI is supplying, feel free to join us. Again, registration is free and is open, and I hope to see you there. All right, thank you, everybody.